Hi, in this video we are going to create a GPT chatbot that will answer the questions based on our website. So we are going to scrape our website for all the information that we need, and we are going to feed this information to the GPT chatbot. In order to do this, we are going to use the Langchain. Langchain is the framework for large language models, which means that on top of just a large language model, we can create a complex logic around it. In our case, we are going to create an index that will find relevant information based on user input and will feed it to the prompt that will go to the large language model. So I am going to create a chatbot that answers the question about the immigration and residence in the Netherlands. Because guess what? I am an immigrant in the Netherlands. So you can see by the flowers. When I was living in Italy, I was filming behind the mountains. And to make sure that the answers are correct, I am going to use the information from the official government website. So let's see for a moment how it works. I have my GPT agent here, and I place the question how to get a visa for my partner if I have a highly skilled visa. You can ask any question about the immigration, it will be able to answer it. You can go to this website, I will leave it in the description. And when I click Analyze, we should wait a little bit because all the queries to large language models take some time. It takes time to receive the answer from them. That also means that we have to design the login states for these experiences. So we'll wait for some time and hopefully we can get some answer. Alright, it gave me the answer. You will need to provide copies of passport, blah blah blah. Not the best answer that I expected, but this can be fine-tuned also. And we have our sources here. So let's go to the sources 1, 2, 3, 4. And all the sources are here. Checklist, documents, required amount of income requirements. Again, the checklist, it took 2 chunks of information on this page, and this one, it found something irrelevant, which is also useful to know. So that's why it's also important to provide sources, so people can check if it is relevant sources or not. And today we are going to create only the backend part of it. And if you want to learn how to create a full stack application with GPT and with your custom data, then I'm thinking to prepare a course for you. So if you're interested, go to the description and join the waiting list, because this kind of course will take a lot of time from me, so I first decided to understand if there is demand for such information or no. So if you want to have this course, please let me know, then I will create it for you. Let's see for a moment how it works. We have our data, in our case the website, but it can also be something else, for example a PDF, and I've already made a video about creating an index from PDF, it's the previous video, check it out also. It can be any document, it can be a spreadsheet, it can be even Figma files. So Langchain allows us to take this data and make an index out of it. What is index? Large language models cannot take an infinite amount of data in one go. They have a token limit, which means that you can feed only a certain amount of characters to the large language model. And that means that you cannot just feed all your documents to the large language model and expect any answer. What we are going to do instead is to create an index. Index is a vector store database that keeps the chunks of information. So we are going to break our data into small chunks that can be fed to the large language model, and we are going to keep it in that database. And in order for us to find the relevant chunks of information, we need vectors. That's why it's vector store database. So vectors is the numerical data that let's say keeps the semantic meaning, which means that when we query our chatbot, it is able to find relevant chunks of information based on these vectors. Alright, so we are going to create a similar logic, but only the backend part. And we are going to use Pinecone to store our vector store database, and we are going to use Langchain. So first thing that you have to do is to create an account in Pinecone. Currently they have a waiting list also because the demand is so high for their services that they had to create a waiting list. So today I will show you how to do the same logic without Pinecone, but Pinecone is actually one of the simplest way to do this kind of application online. So without Pinecone, it's more difficult to deploy it. So I would advise you, if you don't have the Pinecone account, go now and join the waiting list. Today I'm going to show you how to create a vector store without Pinecone, but once you have a Pinecone account, you know what to do. Alright. So I already have my account and I already have an index that I've created. I'm going to delete this one and we are going to create an index one more time together. So for now I don't have indexes, and let's go to code now. I'm going to share with you this code so you can copy it and repeat everything. First we have to install our dependencies. Alright, the dependencies are installed. Now we have to insert our API keys. First, for OpenAI API, we are going to use OpenAI. So to do this, you also have to create an account if you don't have an account yet. And you go to your account, view API keys. Here you can see all of your keys. Now I'm going to create a new one. And this will be demo YouTube. I'm going to disable it right after I record this video, so please create your own API key. We copy this and we go to our code and just insert it here. Alright, the next part is API key for Pinecone. Assuming that you already have an account for Pinecone, we need to create an index to have an API key. No, we have an API key without index. Alright, that makes it even easier. So we copy API key. I will also renew it after I record this video. So create your own, please. Here I will insert API key from Pinecone, and here I also have to insert environment name. So environment name is here. We are in app.pinecone.io. And in API key, you have environment name here. Alright, we did that. And next, let's see. Yes, we did everything for Pinecone. And next, we have to create our index. First, we need to scrape the information from the website that we want and temporarily load it to the docs object. I'm going to use Langchain document loaders, and you can check the documentation for more detail. But how it works, I need to provide the sitemap to this loader. In order to find the sitemap, you usually go to the website and you search for something that is called sitemap. And it will open the web page that resembles sitemap, but we need it to be in the XML extension. So let's check if this address is also true for XML extension. Not really. Why it's not working? Alright, it's not working because it's N, and I was also catched last time. So the original website is in Dutch language, so it's usually the main website and then sitemap.xml. But check for your website. Anyway, we found our sitemap and we insert it here. Next, we can also provide filters. For example, IND website is actually pretty big and I don't need all the information from it because a lot of information is on Dutch and it's not really helpful for me to have an answer in Dutch. So I'm going to have a filter that scrapes only the pages that start with this. So ind.nl and then n. This will be my filter, and you can also set multiple filters. For example, you want to scrape your blog, and for example, you want to scrape also your solutions on your website, and you don't want to have anything else. So here you set the filters, and then we just load the data to docs object. Let's run this code, and we have to wait a little bit while we are fetching the pages and loading them to doc. By the way, I've changed the microphone. You were telling that the previous one didn't work well, so let me know if this one will work better. Alright, we fetched our pages, and now we have to split our documents into small text chunks. So in order to do this, we are going to use Langchain text splitter, and we can actually define the chunk size. So you have to experiment with this on your information, which chunk size will work for you. In my case, these parameters worked well, so I'm going to run this code and split the text into the chunks. So now we have our chunks in docs chunks. And we have to create an embedding. Let's also do this. Alright, it is saying that it didn't find API keys. And I think this is because we didn't run this code. So we have to run our code. So we inserted our keys, but we didn't run it. So the system doesn't know yet our keys. Now I run it and the system knows. Same with Pinecone. We haven't used it, so we didn't have any errors about Pinecone, but we are going to use it soon. Now that the system knows our API key, let's try to run it again. Alright, now it works. We have created our embeddings. And now we have to create an index in Pinecone. We haven't created it yet in Pinecone, so let's go here to indexes and first create our first index. We will call it IND because it's the name of the website that I'm using. Then we have to set the dimensions, 15, 36. And that's it, create index. So now we have created an index that is called IND. And this is the name that I'm going to use here. So if your index is called something different, change the name here. And now I'm going to create an index from the documents, from the docs chunks that we have created before. Let's wait while it's initializing, and when it's ready, we are going to run this code. While we are waiting for Pinecone, let me explain what to do if you don't have a Pinecone account yet. You actually need to use ChromaDB then if you don't have Pinecone. So I've prepared the code for you. ChromaDB, it should be a little bit upper. Let me see if I can I just move it? Alright, how to move it? Can I do that? Yes. Alright. And I move also instructions. So if you don't have Pinecone, then you don't run this code, you run this code instead, because this code will use Chroma instead of Pinecone. And Chroma is an open source vector store, so you can use it for free and you don't have to join any waiting list. The reason why we are using Pinecone instead of Chroma is because in Pinecone you don't have to worry about where you keep your data, because here when you create it, it will be in the temporary memory, and when you're deploying your solution, you have to worry where you keep it. So it's a little bit more difficult. We are going to use Pinecone. Let's see if it is ready. Alright, now it's ready and we can run this code that will create a doc search for us. After you run it, and for example, you did it once and tomorrow you want to do something with the code again, you don't have to create the index over and over again. So when you create the index, you just comment this code and comment this line. So this line will allow you to use the existing index. So you don't have to run all the scrapers, all the text splitters. You just run this where you're using the existing index. But we haven't created ours yet, so we have to uncomment this part and create our index. Alright, we have created our index. Let's go to Pinecone and see what we have created. So in index info, we have now 3000 something vectors. That means that all the information is there. Awesome. Now we can check that it finds relevant chunks of information based on our query. And I'm going to use the same query. Actually, I don't know why I typed this twice. Anyway, I'm just trying to find the documents for this query, so the relevant documents. And I'm printing now the first one. So highly skilled migrant, blah, blah, blah. It seems like we found the relevant information, something about highly skilled migrant and the company family members, which is what we asked it, blah, blah, blah. And if we go to metadata, so this is the metadata, then we have the document source, which is here. So source and the link is here. Checklist documents online application highly skilled migrant, the same page that we have seen in the beginning. And I guess here there is some information about the family member. Yes, it's here. So it found this chunk of information, which is awesome. Because at first I was worried that it found something irrelevant when we were testing. But no, it is a relevant document, and we also can see, so now let's comment this, we also can see how many documents it is finding for the query. We have to print the length of the document. Yes, it found 4 documents for us, so every time we are using 4 documents, which is the same as here, so yeah, it's working. And this is awesome. I will comment, no, I will delete this, we don't need, and I will uncomment this for you. And now we have to create a question answering chain that not only finds the relevant documents, but will send this together with your query to large language model and will compose an answer. To do this, we have to create a question answering chain, and it is saying that it doesn't find these 2 things. I think because I have deleted them before, so let's troubleshoot it together. So it is saying that it's not finding retrieval QA, and it means that we have to import it. Let's see how to import it. QA, yes, thank you. From template. We have to import this. All right. And then we have to define our large language model, which in our case will be the OpenAI. I copied this part, but they're defining it. There are several examples, and they're defining it all the time. So you can find it in several places. Anyway, we just defined that we are going to use OpenAI and the default model, which I think is DaVinci. If you have the access to GPT-4, I would advise you to use GPT-4 because it definitely works better. Then you have to specify the model name, but we will just use the default. And it's also not finding OpenAI because we also have to import it from Langchain. All right, I think that's ready. Let's run this first. And now let's create a question answering chain. We are going to use retrieval QA, which stands for question answering chain. And here you can find more information in the documentation for Langchain. And we are going to use large language model, in our case, the default from OpenAI. The default model is defined by Langchain, not by OpenAI. Langchain defines the default model, and that's why I don't have to specify it here. And then we use our doc search as the retriever, which means we are going to use our index, which is called doc search. So if you use Pinecone, then it is from Pinecone. If you use Chroma, then it is from Chroma. And we want to return source documents. That's true. And same query. All right, let's run it. The code is completed, and the reason why you don't see anything here because we didn't output yet anything. So first, let's see the source documents for the result. So we write our result here, and for the result we have source document and the result itself. So first, let's see source documents. And we have 4 documents as we had before. We have the content. So you can see based on which information the answer is given, and we have the source itself, which is awesome. And now we are going to see the result. So this is the result that I get from this question answering chain. Actually, I think that it doesn't make sense to have the result separately, so I am going to have it here, and I will delete this part. So you'll get the result right away, because it's not really obvious why it's not working. Because it's working, but we are not printing anything. Alright, that's great, that's how it works. I'm going to share the link to this codebase in the description. And if you want to learn how to make a full stack application with Langchain, then also let me know by joining the waiting list, so I know that there are people who are interested in such kind of information, and then I will create a course for you. If this video was helpful, give me a like and subscribe to this channel. See you next time. Bye.